This is the last part of protein, which is enzyme. So these are the learning objectives that you must be able to accomplish by the end of this enzyme part. You should be able to define enzyme. Secondly, explaining the nature and function of enzyme. Thirdly is relating enzyme to its substrate. Fourthly, list the function of enzyme. And last is memorize some food application of enzyme. So what is an enzyme? So you have studied catalyst. Okay, so catalyst function to speed up chemical reaction. So enzyme is a biological catalyst. Okay, so it's non-chemical catalyst. Okay. So similarly, like chemical catalyst, enzyme lower activation energy of a substance. Okay. So enzyme is categorized as protein. Okay, so you can say all enzyme are protein, but not all protein are enzyme. Okay. So some enzyme will consist only protein, but most have additional non-protein component such as carbohydrate, lipid, metal or phosphate. Now, this one we have covered in previous part. So a complete enzyme is called hollow enzyme, in which the protein part is called apoenzyme and the non-protein part is called cofactor. Okay, so both of these is called hollow enzyme. So the compound that is being converted in an enzymatic reaction is called substrate. So in enzymatic reaction, the substrate will combine with this hollow enzyme, and then after the enzymatic reaction, it is released in a modified form as indicated in the following figure. Okay, when the enzyme combine with the substrate, it will form an enzyme substrate complex, and this formation is similar like a lock and key concept. So if you use the wrong lock for a particular door, you won't be able to open the door. So enzyme function similarly. Okay, you have to use the right lock to open. So you have to use the right key to open the right lock. Okay, this is figure 1 showing the direction of enzyme and substrate. So you have the apoenzyme here, the protein part of enzyme, with a cofactor, a non-protein part of enzyme, when joined together, forming a complete protein hollow enzyme. And then substrate with the right shape, you see here, okay, will form a hollow enzyme substrate complex here. So this is the lock and key concept. It has to have the right shape in order for it to react with the enzyme to form the complex. And then after formation of complex, it will detach from the hollow enzyme after forming the products. Okay, and what is left behind is the original apoenzyme and cofactor. So each enzyme will have its own optimum pH value where it works best. Okay, so most enzyme, the optimum pH is in the range of 4.5 to 8. Um, Here are the example of enzyme and their optimum pH respectively. For amylase, the optimum pH is 4.8, invertase 5, pancreatic alpha amylase 6.9. Some enzyme will have broader optimum range, mean it's not specific to one value only. For example, pectin methyl esterase, the optimum pH is in the range of 6.5 to 8. Some enzyme have optimum pH at a very high pH value or very low pH value. For example, pepsin is very will have optimum pH very acidic value, which is 1.8. Arginase very alkaline pH, which is pH 10. Remember the characteristic of enzyme. Enzyme is considered as protein, so the the as the temperature increase, the activity of enzyme also would increase, but it will have cut off temperature, which is 40 degrees Celsius, in which the enzyme will denature. So when the enzyme become denatured, it will lose its enzymatic function. Next, we move on to the naming of enzyme. Now, normally the enzyme name ends in ASE, ASE. So if you see those end with ASE, those are categorized as enzyme. And the name of the enzyme will follow its substrate. For example, if the substrate is urea, then the name of the enzyme would be urease, not ASE, okay, at the end. If the substrate is lactose, mean the enzyme is lactase. Or it can follow the type of reaction that it undergoes. For example, if the reaction is hydrolysis reaction, then the enzyme responsible for this reaction is hydrolase. Okay, if the chemical reaction is oxidation, then the enzyme is oxidase. If the reaction is hydrolysis, then the name is hydrolase. Okay. However, not necessarily all enzyme will end with ASE. Okay, there are exceptions to this, but not many. Okay, for example, ficin found in figs, buatin. So ficin is the enzyme. Papain is the enzyme found in papaya. Next, we move on to the properties of enzyme. So what is the function of enzyme? So enzyme is responsible for ripening, especially in fruits. And it can also cause food spoilage. Remember, we discussed this in Learning Unit 1. Enzyme responsible for the rancidity of butter. Okay, so that is one of it. Enzyme also responsible for change in flavor, change in color, change in texture, and also change in nutritional properties. Now, due to the property of enzyme as protein, it can be inactivated by heat. Okay, in order to extend storage stability of food, especially vegetables and fruits. For example, if you want to export fruits, the transportation will take time, and you don't want the food to get spoiled during the transportation due to ripening process. So therefore, the enzyme that responsible for the ripening of the fruits can be inactivated by heat through process we call blanching. So the fruits are immersed in very hot water for a particular time, let's say 10 seconds, okay, just to inactivate the enzyme. So enzyme also used for fermentation purposes in food, and also can be extracted and purified to a high degree. Next, we move on to classes of enzyme based on chemical reaction that it undergoes. There are 6 types of classes of enzyme based on reaction. The first one is oxidoreductase. Second one is transferase. Third is hydrolase. Fourth is lyase. Fifth is isomerase. And sixth is ligase. So we'll focus only on hydrolase. So this type of class of enzyme is involved in hydrolysis reaction. So hydrolysis means it involves water in the formation of the product. So here, for example, substrate is AB, so it react with water to form these two products here. So hydrolase classified on the basis of the type of bond that is being hydrolyzed. The example of bond that are hydrolyzed by hydrolase enzymes are examples such as ester bond, glycosyl bond, peptide bonds, and also CN bonds. So one example of enzyme involved in hydrolysis of ester linkage is called esterase. So the product form are acid and also alcohol. So triglyceride are hydrolysed by lipase. For example, in LU1, I give you example on lipase reaction on butter. So butter are made of fatty acids. So the major components are triglycerides. So phospholipids is the substrate here, hydrolyzed by phospholipase. Cholesterol ester hydrolyzed by cholesterol esterase. Lipase is example of esterase enzyme, so involved in hydrolysis of ester bond. So lipase produced by microorganism such as bacteria and mold, and they are also produced in plant, also present in animal, for example in the pancreas, and also present in milk. So lipase cause spoilage of food due to the formation of free fatty acid. Okay, so I have mentioned in learning unit 1 that lipase action on butter, for example, cause rancidity, so undesirable to food, okay, due to the formation of free fatty acid. So we'll look in much more detail of the mechanism involved in the following learning unit. In other cases, the action of lipase is desirable. For example, in cheese making, so it will improve characteristic of the cheese flavor. So that's one example of a desirable action of lipase enzyme. So this is the mechanism of lipase in the hydrolysis of ester bond. Okay, and this will result in the formation of fatty acids, okay, the mono and diglyceride. So initially it's triglyceride, okay, 1 2 3, and in the presence of lipase enzyme, it will break the fatty acids okay, ester bond, okay, of the triglyceride. So it will form mono, okay, mono, and also di, okay, diglyceride. So this graph shows the pancreatic lipase hydrolysis of tricaprylin. Okay, so this is lipase hydrolysis in the pancreas. So this axis shows the percentage of glycerides. So you have triglyceride initially at high percentage, and due to the presence of lipase in the pancreas, it is hydrolyzed, okay, hydrolyzed into mono and also di. So mono and di initially at very low percentage. So when this hydrolyzed, forming this, so initially this will decrease, okay, and this will increase, okay, the diglyceride and also monoglyceride. Okay, this table here shows the free fatty acid content in milligram per kilogram of food in different products. So you can see in cheese the free fatty acid is very high, and also here for cheddar 1793, blue cheese 23,500 to 66,700, okay, due to the lipase activity, okay. Next, we will move on to different application of enzyme in food industry. For example, carbohydrates, so that is the substrate, okay. So this is important in the production of corn syrup from starch. So glucoamylase is specifically the enzyme used for the production of corn syrup from starch, means alternative to the formation of sugar, okay. Another example is conversion of cereal starch into fermentable sugar in malting, baking industries. So this example of enzyme is amylase. So next is protease, group of enzymes, specifically bromelain, papain, or ficin as meat tenderizer. Okay, so this is example of desirable lipase activity in the production of chocolate and cheese flavor. This is another example, okay, glucose oxidase in the preparation of salad dressing, pectinase enzyme for clarification of fruit juices. Besides that, it can also increase yield of juice from grape and other fruits. Removal of excess pectin from juice before become concentrated. So there are many applications of enzyme in the food industries, okay. You don't have to memorize each and every example, but at least you should know a few, okay. This is one of the important enzyme in flour, okay, lipoxygenase. So that's why most flour is white in color due to the bleaching. And why tea, cocoa, coffee, raisins are dark in color due to the presence of phenol oxidase enzyme. Again, we will cover this mechanism of reaction between phenol oxidase in the following learning unit, which is minor component, okay, under vitamin. This is another example, cheese production. Okay, so specifically chymosin enzyme. Note that this is one of the exception of enzyme without the ending ASE. Okay, another example, flavorase for restoration and enrichment of flavor. Okay, when the enzyme added to product. Okay, this table sum up the different type of enzyme in different food products and the purpose of the enzyme in these products, food products. Okay, so there are many examples here that you can go through, and that concludes the second learning unit, which is protein.